Okay, hello everyone. Okay, this is the part two of your homework 1070. Okay, last video we just finished the first part. We answered the angle of twist as C. Okay, and there's a second part. Okay, compare the maximum shear stress in the brass and steel. Okay, and then we just okay, here is just open. This is just we have calculated on the first. We have calculated from the first problem. Okay, and okay, we'll use this information to answer the second part of the questions. Okay, so you want to determine the maximum shear stress and maximum shear strength in the brass and steel. Actually, if you know the maximum shear stress, you naturally have the maximum shear strength. Okay, so the key is calculate maximum shear stress. Okay, in the in the torque loaded member, what's the shear stress formula? Okay, it's equal to TC or T rho over J. Okay, J is the polar moment area, T is the torque, and rho is the distance from the center. Okay, distance from the center. Okay. And okay, so you want to determine maximum shear stress, and in the torque loading member, the maximum shear stress is always at the surface. So I just I'll so if this is the maximum, this will be your radius. So I change it to okay, I just change it to R. Okay, I know in this textbook he uses C's for the radius, but but I mean C is sometimes it's very hard for you to think C is a radius. So I just use the R for radius because maximum shear stress is always at the surface. So the rho is equal to R. Okay, and the prop and he said, okay, maximum shear stress, and be careful the shear stress. Right now we have two. You have test for the steel, for the steel. You have to calculate maximum shear stress at the AB part, and at maximum shear stress at the BC part for steel. Okay, because the torque at the AB and torque at the BC, because AB is made of steel. So the TAB is 75, but in BC part, the steel only has in its coaxial part, the steel is in shell. The shell is made of steel. So the torque for the steel at the B torque of steel at the BC part is only 72.5494, 72.5494, and also at the AB part, the AB, JAB and the JAB and JBC steel are different. Okay, so you have to calculate the maximum shear stress at AB and BC for steel. Okay, and then you compare them and determine the maximum shear stress for steel. Okay, for brass, it's much simpler. The brass is at the core, so you just determine the maximum shear stress at the brass surface. And in the previous section, we already calculated the torque for the brass. So we know the value, and we also know the polar moment of area for the brass. Okay, BC brass, and we know the value. So it's very easy to calculate maximum shear stress for brass. Okay, so that's the scheme for this calculation. So let's start with this calculation. First of all, let's calculate the shear stress for the AB. Okay, and it's made up all by steel, so I don't have to identify this as a steel. Okay, so we will have a TAB, and what's the radius? And AB radius is 25 millimeter. Yeah, look at this graph carefully. It's 25 millimeter. Okay. And what's the JAB? JAB is here. So JAB. Nah, maybe. Okay, so it's very easy. So 75 times 25, 10 to the power minus 3 divided by 6.1328 times 10 to the power minus 7. So this will torque AB. And this is the maximum. Yeah, I should say this is maximum. Okay, what's the value? Okay, let's see. If you use your calculator correctly, what's the value for phi AB maximum? Phi, sorry, shear stress AB maximum, shear stress AB maximum, shear stress AB maximum. Let me find the value. Yeah, if you use your calculator, I think the value would be 3.057, 3.057 and megapascal. Okay, that's the value for AB. Okay, and next, okay, we have to this for we have to calculate the steel. Okay, steel for the BC section. Okay, the steel for the BC section. Okay, steel for BC shear stress DC, but it's from steel. Okay, and it's max. Okay, so we need to know the T in BC section, but it's from steel. It's from steel. And the radius, yeah, radius is the same, 25. Yeah, the same. Let me see, the same. Yep, yep, 25 times 10 to the power minus 3. That's the radius. And the polar moment area of the for steel in BC section. Be careful, because this is a coaxial part. So the polar moment area for the shell, okay, is in the B section is different from the polar moment area in the AB section. So we calculate this value before. See here, JBC steel is this value. So they are not the same. Okay, so it's 5.7495 times to 10 to the power minus 7. Okay, so we have BC steel. BC steel is we calculate about less problem 72.5494 times 25 10 to power minus 3. So and 5.7495 5.7495 10 to the power minus 7. Okay, okay, let me see, man. My result, not result, my number is right. So it's BC section for steel, 7225, 5.7495. Okay, so you will have the if so 3.1546 megapascal. Okay, so you compare the steel in AB section and steel in BC section. You see the shear stress, maximum shear stress at AB is only 3.05, 0.75, but the maximum shear stress at BC is 3.1546. It's slightly different, but the maximum is here. Okay, and so if you have shear stress, so what's the shear strain? Okay, so maximum shear strain, let's say it's from BC part and from steel, it's max. Yeah, you just use the shear stress divided by shear modulus. What's the modulus for the steel? 75 times 10 to the power 9, 75 gigapascal. So the value would be, yeah, if just use your calculator again. It's equal. It will be 4.206 times to the 10 to the power minus 5. It's radians. Okay, it's radian. Okay, so we finished the steel part. Okay, and then the final one is the brass part. The brass we only have the 5BC and the brass. Okay, so do I have the space here? Okay, maybe I don't have space here. So I erase this part. Okay, let's finish this problem. It's going to be finished. Yep, just to be a patient. Okay. Okay, so we have the breast part. Okay, so it's shear stress. BC because the breast is in BC section. So breast and the max. Okay, so we need to know the torque at the BC ends from the breast. And then the maximum, okay, maximum. So maximum is at the surface. So the surface for the breast part, the radius is 12.5 millimeter. Be careful. Be careful. This is 12.5 millimeter. Be careful. And what is the J for this breast part? Okay, for J for breast part, J for breast. This is not here. J for breast is this value. So it's 3.833 times 10 to the power minus 8. So this breast part, we just need the breast part. And so, okay, and what about the torque at the BC and from the breast? BC from the breast. So it's 2.4506. Yeah, it should be race. Okay, so it's 2.4506 times 12.5 times 10 to the power minus 3. And 3.833 times 10 to the power minus 8. Okay, final. So what's the value of this? Okay, what's the value of this? What's the value of this? Okay, so if you use the calculator to check the answer, so the answer will be, let me see, BC breast 0. It will be 0.7992 megapascal. Okay, same thing. If you want to calculate the maximum, this is the maximum shear stress for the breast part. Okay, and if you want to calculate maximum shear strain at the breast part. Okay, so it's breast BR max. Okay, so you just use the shear stress divided by the shear modulus of your breast. Okay, so so the shear modulus of breast, and I remember it's 39 times 10 to the power 9. And the shear stress, maximum shear stress is 0.7992 times 10 to the power 6. So just use your calculator again. So what's the shear strength? Let me see. Shear strength. Okay, 2.103. 2.103 times 10 to the power minus 5, and it's radians. Okay, so we finally finished the problem. This is the second part. So yeah, once you have this information from the first problem, it's very easy to determine the maximum shear stress at each part. Okay, and you must understand the maximum shear stress always at the surface. Okay, so for the breast part, you just need to calculate the shear stress at the surface. And for the breast part, yeah, you have to know the radius for this part is only 12.5 millimeter. Just be careful. There's some details. You just don't. Yeah, you have make sure you fill in the right numbers. Okay, sometimes you fill in the wrong number and you find everything is wrong. Okay, that's uh very annoying things. Okay, because lots of formula and lots of physical quantity, and you must make sure you fill in the right number in your equation. Yeah, that's very. So you need to read. You really need. You have to be very careful when do engineering calculation. Yeah, even if you have calculator, but that doesn't mean guarantee you that you must have the right answer. Yeah, you must be very careful for each number you put in. Okay, so I just finished the video here. Okay, see you in another video. Bye bye.